Show that for constant acceleration, the average velocity is given by v naught plus v over 2. So recall that v with that little bar above of it is another way of symbolizing average velocity and or average speed. So one way I could look at this maybe, this is a formal example, so I think at some point I'm just going to show what's on the slide because these formal examples tend to get a little bit mathematical, but I often like to explore. I don't always do this. Sometimes we just look at the slide because that's easier, but I think one way of approaching this kind of a question is to recognize that the definition of velocity, or really average velocity, was based on displacement over time, and displacement was really like final position minus initial position. Oops, I think I found a spot in my screen that my pen didn't write. There it goes. Okay. Sometimes that happens. Technical difficulties. Anyways, x minus x naught over t. And maybe one way to approach this, if I take at face value some of the kinematic formulas that I already have. Well, one of the kinematic formulas I think that I have actually has like an x minus x naught is equal to v naught plus v over 2 times t. So what if I were to just plug that into here, and the thing to see that happens is I would get v naught plus v over 2 times t all over, oops, t, hope you can follow. I crossed my 2 out, I guess I killed it, I don't know. But I can cancel out those t's there, and then that just winds up being equal to v naught plus v over 2. So that's kind of cool. In that sense, the fact that this quantity right here appeared in the third kinematic formula kind of explained why average velocity could be thought of as equaling this formula. One thing I really want to stress is this only works for constant acceleration because this third kinematic formula is only valid for constant acceleration. And that's something, I mean, I kind of presented these formulas. I haven't derived all of them. If you really want to see why is it that these formulas are based on constant acceleration, that's kind of a calculus question. We scratched the surface a little bit when we were going through medieval laws of falling, and we were looking at some of the connections between like average velocity and final velocity, and thinking about that kind of stuff, and thinking about like areas under curves. That's kind of calculus a little bit there, but really in this class we're only going to go so deep on that. But one way to approach it, I think that if we look at the answer right here, it kind of does what I just did at the very end. Is it said here, okay, v bar is equal to delta x over t is equal to the difference of x minus x naught over t. And then, I guess it used, sometimes I forget which version I have for the third kinematic formula. I just straight said x minus x naught plugged in, but I think the one we were working with is x is equal to x naught. That's just x naught on the other side, right? Added to the other side, is equal to v naught plus v over 2 times t. And if you plug that in for x here, it winds up simplifying to that same result. But what this answer has done before that I didn't really do is it actually is showing here how from the first two kinematic formulas that describe constant acceleration, if you solve for acceleration in the second, which really is just the definition of acceleration, plug that into the first, that's actually where that third formula comes from. So one way of thinking about how these first three formulas relate is it's really just a matter of algebra. In some senses, it's the first kinematic formula is like the formula that describes constant acceleration in general, and it's really just a generalization of the Galileo formula, d equals 1/2 gt squared, except g is an a here instead. In other words, the free fall formula, but allowing for an initial position and an initial velocity. So really there's a lot of math behind the scenes here, but these formulas really do work. And again, the added concept here that I think is really cool to know, like why did we do this example, is that the average speed is just the initial speed plus the final speed divided by 2 for constant acceleration. And something that's cool about that is this is really just the arithmetic average. If you average two numbers, it's the same formula.